Triz. Triz is the Russian acronym for the theory of the inventive problem solving, an international system of creativity developed in USSR between 1946 and 1985 by engineer and scientist Genrikh S. Altshuler and his colleagues. According to Triz, universal principles of creativity form the basis of innovation. Triz identifies and codifies these principles and uses them to make the creative process more predictable. In other words, whatever problem you are facing, somebody somewhere has already solved it. Creative problem solving involves finding the solutions and adapting it to your problem. Triz is most useful in roles like the product development, design engineering, and process management. For example, Six Sigma quality improvement processes often makes use of Triz. The Triz tools. So let's look at the two of the central concepts behind Triz: generalizing the problems and solutions and eliminating the contradictions. Generalizing problems and solutions. So problems and solutions are repeated across industries and sciences. By representing a problem as a contradiction, you can predict the creative solutions to that problem. Patterns of technical evolution tend to repeat themselves across industries and sciences. Creative innovations often use scientific effects outside the field where they were developed. Using the Triz consists of learning these repeating patterns of problem and solution, understanding the contradictions present in a situation, and developing the new methods of using scientific effects. You can then apply the general Triz patterns to the specific situation that confronts you and discover a generalized version of the problem. Eliminating contradictions. Another fundamental Triz concept is that there are fundamental contradictions at the root of most problems. In many cases, a reliable way to solve the problem is to eliminate these contradictions. Triz recognizes two categories of contradictions. Technical contradictions. These are the classical engineering trade-offs where you can't reach the desired state because something else in the system prevents it. In other words, when something gets better, something else automatically gets worse. And the physical contradictions, these are the situations in which an object or the system suffers contradictory opposite requirements. Everyday examples includes software should be complex, coffee should be hot, and umbrella should be large. So how to use this Triz principles? Example like being to explore Triz by applying it to a simple practical problem. For example, consider the specific problem of a furniture store in a small building. The store wants to attract the customers, so it needs to have its goods on display. But it also needs to have enough storage space to keep a range of products ready for sale. So using a Triz, you can establish that the store has a physical contradiction. The furniture needs to be large. Using the Triz, the store owners generalize these contradictions into a general problem and apply one of the 40 principles of problem solving. They find a viable general solutions in principle 1 segmentation, and these advocates dividing an object or the system into different parts or making it easy to take part, and this could lead the owners to devise the flat pack versions of their furniture so that the display models can take up the room that they need while inventory occupies much less space per unit. And this is the specific solution.